Everyone, good evening. So here we shall solve some KCET previous year questions, the chapter waves. Um so if you have any questions regarding any of the steps of the solution or any other kinds of doubts if you have, then please write us in the comment section. Uh, Also, if you feel if you have that you have more difficulty in any of the chapters of physics, then also please mention the name of that particular chapter in the comments section so that we can solve more questions on it, which shall be helpful for your KCET exam. Uh, Also, the homeworks on every chapter will be uploaded in the Sapience Education application. So please install our Sapience Education application, whose link has been provided in the description. So here we shall start off with the very first question on the chapter of waves in physics. So it is told a tuning fork A produces 4 beats per second. Tuning fork A produces 4 beats per second. Another tuning fork B of frequency 320 Hz. Filing one of the of A, 4 beats per second are again heard when sounded with the same fork B. Then the frequency of fork A before filing. We know that the beat frequency is given as frequency of A minus frequency of B. So the absolute value of that is called beat frequency. So now it is told that so on filing, we know that on filing the frequency will increase. On filing one of the prongs, on filing one of the prongs of the tuning fork, filing one of the prongs of the tuning fork, the frequency increases. Increases. So it means here it is that we can say that nu B minus nu A, that is equal to 4 when when uh, when the fork A is not filed. You can say before filing, and nu A dash minus nu B, that is also equal to 4 after filing. So now therefore we can say that 320 minus nu A, that is equal to 4, and nu A dash minus 20, that is equal to 4. So it means that nu A dash, that is equal to 320, and nu A, that is equal to 316 Hertz. So now it means that after filing one of the prongs of the fork A, of the tuning fork A, the frequency will be 324 Hertz, and before filing will be 316 Hertz. So option B is the correct answer. Then it is told when the length of the vibrating segment of the sonometer wire is increased by 1%, the percentage change in its frequency is. So we know that the frequency of a sonometer, the frequency of the vibrating segment of sonometer wire, the frequency the vibrating segment of the vibrating segment of a sonometer wire is nu equal to 1 by 2L, equal to 1 by 2L into root over T by mu. 1 by 2l root over t by m, sorry, root over t by m. So here mass will remain constant, and T is the tension in the wire. T is the tension in the wire. M is the mass of the wire, the sonometer wire, mass of the wire, and L is the length of the sonometer wire, length of the sonometer wire. So here it is told length of the vibrating segment is increased by 1%, and the percentage change in the frequency. So from here we can say that delta nu by nu, that is equal to delta L by L, since T and M, all these are constants. So remaining all the quantities are constants, so the frequency is depending on the length only. Now therefore here it is told length is increased by 1%, so therefore delta L by L, that is 1% means 1 by 100 given. So therefore delta nu by nu also will be equal to 1 by 100, that is 1%. So the percentage change in the frequency will be also 1%. So option C is the correct answer. Question number 3, it is told the equation of a simple harmonic wave is given by y equal to 5 sine pi by 2 into 100 t minus x, where x and y are in meter and time is in second. Then the period of the wave in second will be, so we have to find the time period of the wave. We know that time period t will be equal to 2 pi by omega, 2 pi by omega, where omega is the angular frequency of the wave. So we know that if the equation is of the form y equal to a sine kx, a sine omega t minus kx, then the coefficient of t will be the angular frequency omega. So here you can see that omega equal to 50 pi is 100 pi by 2. So therefore the time period will be 2 pi by 50 pi. So pi and pi will cancel. So 2 by 50 is 4 by 100. 4 by 100 means 0.04 seconds. So the time period of the wave is 0.04. Option A is the correct answer. Then in question number 4, it is told the loudness and pitch of a sound note depends on the, you know that loudness depends on the amplitude. Loudness depends on the amplitude, and we know that intensity is proportional to the square of the amplitude. So loudness, we can say it depends on the amplitude or the intensity of the sound wave, intensity of the sound wave, and the pitch of the sound, pitch depends on the frequency, pitch depends on the frequency of the sound. Therefore option A is the correct answer, that loudness depends on intensity and pitch depends on frequency. Okay, then in question number 5, it is told the maximum particle velocity in a wave motion is half the wave velocity. The amplitude of the wave is equal. The maximum particle velocity means, you know that y equal to a sine omega t minus kx. This is the equation of a traveling wave. This is the equation of a traveling wave. Traveling wave. So therefore the particle velocity, therefore the particle velocity in the wave, that is given as Vp, that is equal to dy by dt, particle velocity, and the wave velocity, that is given as omega by k, since omega is pi by 2 pi into frequency and k is 2 pi by lambda. So we know that speed of a wave, that is given as frequency into wavelength. So wave velocity is omega by k. So now here dy by dt, maximum particle velocity, it is equal to half of the wave velocity, that is omega by k. So maximum particle velocity, it means we have to find the maximum value of dy by dt. So that is equal to half of omega by k. So dy by dt is a omega cos omega t minus kx. A omega cos omega t minus kx. So therefore, the maximum particle velocity will be a omega. So a omega equal to omega by 2k. Omega and omega will cancel. So a is equal to 1 by 2k. So k is equal to 2 pi by lambda. So 2 into 2 pi by lambda. So that is lambda by 4 pi. So this is the amplitude of the wave, which is lambda by 4 pi. So option A is the correct answer. Okay. So if you are unable to understand any steps of the solutions or any other kinds of doubts if you have, then please write us in the comment section. Then here it is told the ratio of the velocity of sound in hydrogen to the velocity to that in helium at the same temperature is the ratio of the velocity of sound in hydrogen to that of velocity in helium at the same temperature, that is how much. So we know that velocity of sound in gases that is given as square root of gamma RT by m. So it means that if the temperature is constant, then so therefore you can say the velocity of the sound that will be proportional to root over gamma by m, where m is the molar mass of that gas and r we know that is universal gas constant. So that is proportional to gamma by m if the absolute temperature is constant. If temperature is kept constant, means in the isothermal condition, okay, so if the temperature is constant, so then um, so it means velocity of hydrogen that will be we can say that is root over gamma of hydrogen by molar mass of hydrogen divided by the root over gamma of helium divided by molar mass of helium. So that will be square root of gamma of hydrogen, that is given 7 by 5, divided by molar mass of hydrogen. Molar mass of hydrogen, we know that it is 1 gram. Okay. That divided by square root of gamma of helium, that is 5 by 3, divided by molar mass of helium, that is 4 gram. This will come, that is root over that is 7 by 5 into that will be 12 by 5. So this will be 12 sevens. Okay, so this will be is 5 by 3 by 12, 7. So this is coming root over 84 divided by 25. So this is root over 84 by 5. So it means that none of the options are correct. Then in question number 7 it is told an engine is moving towards a wall. An engine, there is a wall, fixed wall, and one engine is moving towards it. An engine is moving towards it with a speed of 50 meter per second, and it emits a note of 1.2 kilohertz, means it is 1200 hertz. Speed of sound in air, speed of sound, that is u, that is 350 meter per second. The frequency of the note after reflection from the wall as heard by the driver of the engine. So it means that the so initially we have to so with respect to the wall, so let's say the actual frequency nu naught is 1200 hertz, and the frequency which is received by the wall, so that is nu 1. So nu 1 will be equal to the, we know that according to the Doppler effect, by the rule of Doppler effect, we know that the apparent frequency, that is equal to u plus minus v naught by u plus minus vs into the actual frequency. So where v naught is the velocity of the observer and vs is the velocity of the source, and u is the speed of the sound. So nu 1, that will be equal to u here observer with so if we solve, if we have to find the frequency with respect to the wall, it means now observer is at the wall, observer is the wall, and the source is moving towards the observer. So this will be u by u plus minus v, sorry, this will be u minus v, since why source is moving towards the observer, so the frequency has to increase. Source is moving towards the observer, so the frequency has to increase. This will be u minus v into nu naught, and when the reflected sound is received by the driver in the engine, then this engine will be treated as the observer and the wall will be treated as the source. So that observed frequency is nu 2 by the driver, then we can say nu 2 will be equal to, now observer is moving towards the source, it means that it will be u plus v by u minus v into nu naught, or this will be u plus v into by u, since source is not moving here, by u into nu 1. So if we solve it, then we will have u plus v by u minus v into nu naught. So therefore the frequency, that is frequency of the note after reflection from the wall, that is heard by the driver of the engine, that is u, that is speed of the sound in air, that is 350, plus the speed of the engine towards the wall, that is 50, divided by 350 minus 50 into nu naught, which is that is 1200 hertz. So this will be equal to 400 by 300 to 1200. So it will be equal to 3 4s 12 4 4 will be 1600 hertz. So this will be 1.6 kilohertz. So option C is the correct answer. Then here it is told a glass tube is open at both the ends. Glass tube is open at both the ends. A tuning fork of frequency F resonates with the air column inside the tube. The glass tube is there, which is open at both the ends. A tuning fork of frequency F resonates with the air column inside. So here we have a tuning fork. So it will produce some sound that will resonate with the air column inside. Now the tube is placed vertically inside water so that half of the length of the tube is filled with water. Now here it is told that this is now, so this resonates. So let's say it is open at both the ends. So we know that the fundamental frequency, so when there is fundamental frequency, that will be like this. Then we have, this is f naught. So here we can say that L equal to lambda by 2. So lambda will be equal to 2L here. So here the frequency will be equal to nu naught, which is fundamental frequency, that is V by lambda, that is V by 2L. And then the first harmonic, so the fundamental frequency is the first harmonic, then the second harmonic will be somewhat like this. So here we have lambda by 2 plus lambda by 2, that is lambda. So here lambda equal to L, so nu 2 will be equal to V by L, which is equal to 2 lambda 1. So it means that here, and then the third harmonic will be somewhat like this. So here we will have lambda by 2 plus lambda by, so this is 3 lambda by 2, 3 lambda by 2, that is L. So lambda equal to 2L by 3. So nu 3, that will be equal to V by lambda, that is V by 2L by 3. So this is 3 nu 1. So it means that here we will have all the harmonics for an open end organ pipe. We have all harmonics, first harmonic, second harmonic, third harmonic. So let's say we have the nth harmonic here. So then we can say n V by 2L, that will, which is nu n, that is resonating with the tuning fork frequency. Now the tube is placed vertically inside water so that half of the length of the tube is filled with water, half of the tube is filled with water. Now the air column inside the tube is in unison with another tuning fork of frequency f dash. It means that here now half of the length, now here half, so when water is filled, then one of the ends is closed. It means one of the ends is closed. Now here you know that when we have an closed end organ pipe, when we have closed end organ pipe, then the first harmonic is like this, means lambda by 4, that is equal to L. Then we can say lambda equal to 4L. So here we have first harmonic. So for closed end organ pipe, we have only odd harmonics, means we have first harmonic, then third harmonic, it will be somewhat like this. So here we have lambda by 2 plus lambda by 4, that is 3 lambda by 4, that is equal to L. So lambda equal to 4L by 3. So here we have nu 1 first harmonic, that is V by lambda, that is V by 4L. And here we have nu 2, that is nu 3, that is V by 4L by 3, that is equal to 3 nu 1. So for closed end organ pipe, we have odd harmonics only. So here half the length of the tube is filled. So here we have now L by 2, so which will be, we can say it is L dash. So therefore, suppose here we have the mth harmonic. So it will be like 2m plus 1th harmonic. So we can say this 2m plus 1 v by 4 L dash, that is equal to f dash. So it means that, so this will be 4L dash, sorry, 4L dash. It means here we have new 2m plus 1, which is the 2m plus 1th harmonic, that is equal to 2m plus 1 into v by 4L. So this will be 2m plus, so L dash is L by 2, so I can say 2m plus 1 by into v by 2L, that is equal to f dash. Therefore, here so here if these two are same, so if I say that 2m plus 1 that is equal to n, then f will be equal to f dash. So we have to take n as some odd number only. So it means that option A is the correct answer. Then it is told the equation of a simple harmonic wave is given as y equal to 6 sine 2 pi into 2t minus 0.1 x, where x and y are in millimeter and t is in seconds. The phase difference between two particles which are 2 millimeter apart at any instant, so which are 2 millimeter apart, the phase difference between two particles which are 2 millimeter apart, so therefore the phase difference, that is delta phi, that will be equal to k delta x, Since why, if we have uh, if the simple harmonic wave is in the form a sine omega t minus kx, then if the path difference in between two particles in the wave is x1 is delta x, then their phase difference will be k delta x. So if path difference the path difference is delta x, path difference in between two particles in the wave, two particles is delta x, then their corresponding phase difference is k delta x. Their corresponding phase difference is k delta x. Now therefore here we can see here omega is equal to 4 pi, and since y it is of the form omega t minus kx, and k is equal to 2 pi into 0.1. So therefore phase difference delta phi, that will be equal to these are in millimeter, that will be 2 pi by lambda. This is in millimeter inverse actually. Millimeter inverse, that is 2 pi into 0.1 into 2. So this will be to the 0.4 pi radian. 0.4 pi radian means it is actually radian per millimeter. Since here x and y should be in millimeters only, it has been told. So therefore the unit of k, that should be in radian per millimeter, and the unit of omega should be radian per second. So this is radian per millimeter, sorry. So therefore be 0.4 pi radians. So this is 4 by 10 into pi radian means it is 180 degree. So 18 4 that is 72 degrees. So the phase difference in between those two uh, particles which are at a distance of 2 millimeter apart, the two uh, particles in the wave, they are 2 millimeter apart, so their phase difference for the wave will be 72 degrees. So option B is the correct answer. Then it is told, with what velocity should an observer approach a secondary sound source so that the apparent frequency of the sound should appear double the actual frequency. It is told that if the apparent frequency is twice of the actual frequency, then with what velocity should an observer approach the stationary sound source? Then what should be V naught? And Vs is equal to 0 here. Means the observer is, is moving at a velocity. The observer is moving at a velocity V naught towards the source, and the source is at rest. Source is stationary. Means Vs is 0. Is at rest. Source is at rest. Then in what velocity the observer should approach towards the stationary observer? That is how much. So now here, suppose the speed of V, here it is told to take V as the speed of sound. So if V is the speed of sound in air, of sound, then we can say that, then by using the rule of Doppler effect, by the Doppler effect rule, we know that the apparent frequency that is given as V plus minus V naught by V plus minus Vs into nu actual. It means the apparent frequency equal to speed of sound plus or minus the speed of the observer divided by speed of sound plus or minus the speed of the source into the actual frequency. So the so here Vs is 0. So here, so observer is moving towards the source, so the frequency has to increase. So I should say that it should be V plus V naught divided by V into nu actual. So that is given as 2 times nu actual. So these the actual frequency shift will cancel out. Then we will have V plus V naught that is equal to 2V. So V naught will be equal to V. It means that the observer should move towards the source with the speed of sound only. Option B is the correct answer. So in any of the steps, if you are unable to understand, then please write us in the comment section, or any other kinds of doubts if you have, then also please write us in the comment section. We shall clarify them in the subsequent videos. Okay. Then it is told that a string vibrates with a frequency of 200 Hz. A string is there. A string vibrates with a frequency. A string is there. Vibrates with a frequency of 200 Hz. When its length is doubled and tension is altered. Length is doubled and tension is altered, it begins to vibrate with a frequency of 300 Hz. The ratio of the new tension to the original tension is. So we know that for a vibrating string, so we know that the velocity or the frequency is given as the frequency of vibration in a vibrating string. The frequency of vibration in a vibrating string, nu, is given as 1 by 2L root over T by mu, where mu is the mass per unit length. So mass per unit length is constant. Therefore, we can say that nu square is equal to 1 by 4 L square into T by mu. So therefore, the tension in the string will be equal to 4L square mu into nu square. So therefore, we can say that since mu is constant and 4 is also constant, so T is proportional to L square into nu square. So therefore, the ratio of the tension force T1 by T2, that will be equal to L1 square into nu1 square by L2 square into nu2 square. Now here, when suppose the L2 is equal to L and nu2 is 200, double tension, okay, ratio of the new tension to the original tension. Let's suppose T2 is the original tension, this is the original tension suppose, and T1 is the new tension suppose, new tension. So it means that L2 is L and nu2 is 200 hertz, and then L1 is the length is doubled. The length is doubled, it means that it is 2L, and nu1 that is increased, it begins to vibrate with the frequency 300 hertz. And then we have to find the ratio of T1 and T2. So that will be equal to L1 square, that is 2L whole square, into nu1, that is 300 whole square, divided by L square into 200 whole square. So this will be, so 4 L square by L square into, this will be 9 by 4, since 0 0 will cancel, 4 4 will cancel, and the ratio is 9:1. 9:1, so option C is the correct answer. 12, question number 12 is told, how many times more intense is a 60 decibel sound than a 30 decibel sound? So we know that the loudness of a sound is given as 10 log 10 into log of I by I naught, where I naught is equal to 10 power minus 12 uh, 10 power minus 12 watt per meter square. This is the intensity. When loudness is 10 decibel, so when the intensity is this, then the loudness is 10 decibel. So now, so in decibel this is, so now therefore 60 decibel, that is equal to 10 log, suppose I1 by I naught. So then we can say that log of I1 by I naught, that is equal to 6. It means that, and base is not there, it means the base is 10. Is I equal to I naught into 10 power 6. 10 power 6. Then, and 30 decibel, it means 30 equal to 10 logs, 10 into log, suppose I2 by I naught. It means that I2 will be equal to I naught into 10 power 3. So therefore, I1, that is equal to I2 into 10 power 3. Since by this I can write I naught into 10 power 3 into 10 power 3. So it means that I1 is 10, I2 into 10 power 3. So it means that a 60 decibel sound, so a 60 decibel sound is 1000 times more intense than a 30 decibel sound. 1000 times more intense than a 30 decibel sound. So it means that option C is the correct answer. Then here it is told that sound waves transfer only energy, not momentum. Energy, mo- momentum, both energy and momentum. So we know that sound waves transfer both energy and momentum. Sound waves transfer sound waves transfer both energy and momentum. Both energy and momentum. So option D is the correct answer. Then it is told that a stationary point source of sound, there is a point source of sound, it emits sound uniformly in all directions in a non-absorbing medium. In a non-absorbing medium, 2 points P and Q are at a distance of 4 meter and 9 meter respectively from the source. So there is a point which is at a distance of 4 meter from the source, and the point P, no, sorry, this is at point P, and point Q is at a distance of 9 meter from the source. The ratio of amplitudes of the waves at P and Q is. So the intensity will be constant. So intensity is proportional to square of the amplitude. Ratio of the amplitudes here. So intensity is inversely proportional to d square, where d is the so intensity is inversely proportional to d square, where d is the distance of that point from the source, where d is the distance of the point from the source, and I is inversely proportional to d square only if we have a point source. It is applicable only for point source of sound. So therefore we can say that the amplitude is inversely proportional to d. Amplitude is inversely proportional to d, where d is the distance of the point from the source. Therefore we can say that the amplitude at the point P by the amplitude at the point Q, we have to find the ratio of the amplitude of the waves at P and Q. So that will be equal to 1 by the distance of the point P divided by 1 by distance of the point Q from the source of the sound. So this will be equal to the distance of the point Q divided by distance of the point P from the sound. So that will be equal to 9 by 4. So option D is the correct answer. Now here it is told that y equal to 3 sine pi t by 2 minus x by 4 represents an equation of a progressive wave where t is in second and x is in meters. X is in meters and t is in seconds. Then the distance traveled by the wave in 5 seconds is. What is the distance traveled by the wave in 5 seconds? So first we have to find the speed of the wave. So the velocity speed of the wave is wavelength into frequency. That is, we can say it is equal to omega by k. Omega by k. So when we have, so if the equation of a progressive wave is of the form a sine kx, a sine omega t minus kx, then if we compare this, then omega is called the angular frequency and k is the angular wave number of the wave. So here, therefore here omega will be equal to pi by 2. If we come if we compare this equation with this equation, and the angular wave number k will be equal to pi by 4. So therefore the speed of the wave will be equal to omega, that is pi by 2 divided by pi by 4, that is 4 by 2, that is 2 meter per second. Now therefore the distance traveled by the wave, the distance traveled by the wave in 5 seconds will be equal to speed into time. Speed into time, that is speed of the wave is 2 meter per second into the time, that is 5 seconds. So this is 10 meters. So option B is the correct answer. So in any of the steps of the solution, if you are unable to understand, then please write us in the comments section. In question number 16, it is told a cylindrical tube which is open at both the ends has fundamental frequency. So it is like an open-end organ pipe. It is an open-end organ pipe. It has fundamental frequency. Fundamental frequency is 390 Hz in air. Here. And if 1/4 of the tube is immersed vertically in water, the fundamental frequency of the air column is. So it means that 1/4 is immersed in 1/4 of the tube is immersed vertically in water. So this part is under water. Suppose this 1/4 part means L by 4 is underwater, and the remaining part 3L by 4 is in air. Is in air. So it means that now it will act like a closed end organ pipe. So in open end organ pipe, the new one that is given as V by 4L, sorry, V by 2L. Since why here we have is the fundamental frequency is like this, it means that lambda by 2 that is equal to L. So lambda equal to 2L. So new one that is equal to V by lambda, that is equal to V by 2L. And here when we have closed end organ pipe, then the fundamental frequency will be like this. The fundamental frequency of vibration would be like this. So here we have lambda by 4 that is equal to L, lambda equal to 4L, and here the frequency new one that is given as the fundamental frequency, that is V by 4L. Here the length will change. Suppose it is L dash, but the speed in the air that will not change. So means that this will be V by 4 L dash, new one dash, you can say. So therefore here the length which has changed, L dash is equal to 3L by 4. So now new one dash, that is the fundamental frequency of the air column when 1/4 of the tube is inserted in 1/4 of the tube is immersed in water, then the fundamental frequency will be new one, which is V by 4L dash, which is 3L by 4. So this is V by 3L. So now we have, so V by 2L that is given as 390 Hz. So it means that V by L that is given as 390 into 2 Hz. Now therefore the fundamental frequency, new fundamental frequency is V by 3L. So that is equal to 1 by 3 into 390 into 2 Hz. So that will be equal to 13 3 is 39. So it will be 260 Hz. So option A is the correct answer. Then it is told that a bat flies at a steady speed. Bat is there. It flies at a steady speed of 4 meter per second, and it is emitting a sound of frequency 90 kilohertz, means 90 to 10 power 3 hertz. It is flying horizontally towards a wall. It is flying horizontally towards a wall, a vertical wall. The frequency of the reflected sound as detected by the bat. So now in the first case the wall wall can be treated as the observer and the sound of the bat as the source. So therefore, new one, that is the apparent frequency um, as being heard at the wall, that is equal to, you can say here, so this is the speed of the source here. So the speed of sound, we can say, take the velocity of sound u as 330 meter per second. So here we can say it will be u. So actually we know that by using the rule of Doppler effect, the apparent frequency is given as u plus minus v naught by u plus minus vs into actual frequency nu naught. Now here the actual frequency nu naught, that is given as f, which is 19 to 10 power 3 hertz. And with respect to the wall, the observer is at rest and source is moving towards the observer. So it will be u and by u minus vs into u naught. So that will be equal to u by u minus v into f. And the reflected sound will be observed by the bat again. So in the second case, the apparent frequency which is observed by the bat, then the bat will be treated as the observer and the reflected sound is coming, so the wall will be treated as the source here. So now here source is stationary but observer is moving towards the source. So this will be then u plus v by u into nu 1. So that will be u plus v by u into nu 1, that is u by u minus v into f. So u will cancel, so that is u plus v by u minus v into f. So this will be equal to u, that is 330, minus v, that is 4 meter per second, plus by 330 minus 4 into the frequency, that is 19 to 10 power 3 hertz. So this will be equal to 334 divided by 326 into 90 into 10 power 3 hertz. So this will be slightly more than 90, it will come more than 90, so it will be approximately 92.1 into 10 power 3 hertz. So option C is the correct answer. And then a closed organ pipe and an open organ pipe of same length produce 2 beats per second while vibrating in their fundamental modes. The length of the open organ pipe is halved and closed organ pipe is doubled. Then the number of beats produced per second while vibrating in the fundamental mode is okay. Now here we have a closed end organ pipe and we have an open end organ pipe. So both are having the same length. So both are vibrating in their fundamental modes. So here in the fundamental mode we have nu 1, the fundamental frequency of vibration, that is v by 4l. If the length is l, then we can say that the fundamental mode of vibration is like this. So I can say lambda by 4 equal to l. So lambda equal to 4l. Nu 1 is v by 4l. V is the speed of sound. Suppose v is the speed of sound, we are assuming speed of sound in air. And here in the open end we have the fundamental mode is somewhat like this. So here we have lambda, that is lambda by 2, that is equal to l. So lambda equal to 2l. So therefore here nu 1, that is equal to v by 2l. They have the same length. So it is told that the beat frequency, so we can say it is nu 1 dash. Here the fundamental frequency, that is so therefore nu 1 dash minus nu 1, that is equal to 2 beats per second, that is given here. So it means v by 4l, sorry, v by 2l minus v by 4l, that is equal to 2. Means that I can say this is 2v by 4l. So this is v by 4l, that is equal to 2 actually, 2 beats per second. So now here it is told that the length of the open end organ pipe is halved. Length of the open end organ pipe is half. Now it is having the length L by 2, and the closed end organ pipe is doubled. Means now it has 2L length. Then the number of beats produced per second while vibrating in the fundamental mode. So here the fundamental mode of vibration, suppose if I take it as nu naught will be here. Fundamental mode is like this, obviously. So here we can say L by 2, that is equal to lambda by 2. So lambda equal to L. So nu naught will be equal to V by lambda. So V by L. And here it will be like this. So here we have lambda by 2, that is equal to 2L. Lambda by 2, that is equal to, sorry, lambda by 4, that is equal to 2L. Lambda by 4, that is equal to 2L. So lambda equal to 8L. Now here nu naught dash, the fundamental frequency, that will be V by 8L. Now therefore the beats frequency, beats means the number of beats that is heard, that will be equal to nu naught minus nu naught dash. So that will be equal to V by L minus V by 8L. So that is 8 by 8L. So this will be 7 V by 8L. So that will be equal to 7 by 2 V by 4L. So this V by 4L is 2, so it will be 7 beats per second. So option D is the correct answer. Then in question number 19, it is told uniform wear is there, uniform wear of length L, and its diameter is D, and its density is rho, and which is under a tension T. The correct relation between its fundamental frequency, its length, and the diameter D is how much? Is under a tension T. Okay. So fundamental frequency means it is vibrating in its first harmonic. So it will be like this. So lambda by 2, that will be equal to L. So lambda equal to 2L. So therefore the fundamental frequency F, that will be equal to V by lambda. So V by 2L. So this will be 1 by 2L into V. V is equal to root over T by mu. Mu means it is mass per unit length. So mass is density into volume. So volume by length. So this is density into cross-sectional area of cross-section. That is pi r square. So you can say pi d square by 4 into length divided by length. So it is density into area of cross-section. So this will be 1 by 2L into root over T by density into area of cross-section, that is pi d square by 4. So it means that if tension and density is constant, then we can say that the frequency is inversely proportional to 1 by L root over D square. It means that F is proportional to 1 by LD. So option A is the correct answer. Then here it is told the equation of a wave is given by y equal to 10 sine 2 pi t by 45 plus alpha. Now if the displacement is 5 centimeter at t equal to 0, then the total phase at t equal to 7.5 seconds So here it is told that if the displacement, if y equal displacement is 5 centimeter, so it means that if y equal to 5 centimeter at t equal to 0, then the total phase at t equal to 7.5 second, it means the total phase angle means it is, if it is 10 sine phi, right, then this phi which is equal to 2 pi t by 45 plus alpha, this is called the total phase. You have to find that at t equal to 7.5 seconds, that we have to find. Now therefore we can say that 5 centimeter, that is equal to sine, so at t equal to 0, so 5 is equal to 10 sine alpha, so sine alpha, that is equal to half, so alpha is equal to sine inverse half, that is equal to pi by 6, since sine 30 is half, so pi by 6 radian alpha. Alpha is also called as the initial phase. So therefore we have to find the value of 2 pi by 45 into 7.5 plus alpha, that is pi by 6. So that will be equal to uh, 7.5 into 2, that is 15 pi by 25 plus pi by 6, so that will be 5 3 are 15, 5 5 are 25, so the LCM is 5 6 are 30, so then 6 3 is 18 pi plus this is 5 pi. Okay, so this will be 23 pi by 30 total phase at 7.5 seconds. Okay, this is 15. So sorry, this is 550 25. Sorry, this is 45. This is 45. So this will be 15. So 15 3 the 45. Sorry, this is wrong. There is a calculation error. So this will be 15 pi by 45 plus pi by 6. So this is 15 3 the 45. So pi by 3 plus pi by 6. So this is 2 pi by 6 plus pi by 6. So this is 3 pi by 6, which is pi by 2. So pi by 2 is the required total phase at 7.5 seconds. So option B is the correct answer. Excuse me. So here it is told two tuning forks A and B produce notes of frequencies. The notes of frequencies 258 Hz, and the tuning fork B produces a frequency of note of frequency 2 is 62 Hz. An unknown note sounded with A produces certain beats. When the same note is sounded with B, the beat frequency gets doubled. The beat frequency gets doubled. The unknown frequency is. So let the unknown frequency is new. So therefore the beat frequency with A. Therefore the beat frequency with A will be equal to mod of nu minus nu A, and the beat frequency with B equal to mod of nu minus nu B. So it is told, therefore it is given that the beat frequency gets doubled with when it is sounded with B. So therefore of nu minus nu b, that is equal to 2 into mod of nu minus nu a. Then we have to find the unknown frequency nu. So here for the first case we can take, that is suppose this one. Suppose we can take that nu minus nu b, that is equal to 2 into nu minus nu a. Therefore I can say that nu that is equal to 2 nu minus nu, so nu that is equal to nu a minus nu b. So but then the frequency is coming negative, which is not possible. It's not possible. So therefore we, in the case 2 we should include, that is nu minus nu b, that is equal to minus of nu into nu minus. Therefore you can say that nu minus nu b, that is equal to minus 2 nu plus 2 nu a. So therefore I can say 3 nu, that is equal to nu b plus 2 nu a. So therefore the unknown frequency is nu b plus nu 2 nu a divided by 3. So that will be nu b, that is 62 plus 2 nu a, that is 2 into 258 divided by 3. So therefore the unknown frequency nu, that is equal to 258 into 2 plus 262 by 3. Okay, so this will be equal to 262 plus 2 at 16, 10, 1, 5, 516 divided by 3. So this will be equal to 778 divided by 3. So this is equal to 3 ones are 3. So no, sorry, 3 to the 6. 3 to the 6. 15. 28. 3 nines are 27.33. So 259.33. Here the bit frequency, here what can happen, both can be less than both a and b also, can be both less than a and b also. So it means what can happen, can be like the bit frequency with a, it can be nu a minus nu, and the bit frequency with b, it can be nu b minus nu. Now therefore nu b minus nu, that can be equal to twice of nu a minus nu. Since here in the options we see that in all the options the given frequency is less than both a and b. So therefore nu b minus nu, where nu is the unknown frequency, that will be 2 nu a minus 2 nu. So therefore we can say that this is 2 nu minus nu is equal to 2 nu a minus nu b. So that will be that will be equal to 2 nu a minus nu b. This will be equal to 2 nu a, that is 2 into 258 minus 262. So that will be 2 at the 16, 516 minus 262. So that will be equal to 4, and then this is 5, then this is 254 hertz. So therefore option C is the correct answer. Then in question number 22 it is told where under tension, a wire is there which is under tension, it vibrates with a frequency 600 hertz. If the length of the wire is doubled, and the radius is halved, and the wire is made to vibrate under 1/9 of the tension. If the tension is now changed to T by 9, then the fundamental frequency will become. So here it is vibrating with the fundamental frequency only. It means like this. So here fundamental frequency is given as nu naught, that is equal to 1 by 2L root over T by rho A. Now the density in the wire cannot change since the material of the wire is not changing. Since the material of the wire is not changing, therefore the density of the wire will remain constant. So now therefore here it is told that nu naught, that is equal to 1 by 2L. So suppose initially the length was L R and the radius of the wire was R and the tension was T, and then finally the L dash, that is 2L, and the new radius is R by 2 and the new tension is T by 9. So then we have to find nu naught dash. It means that what is the new value of fundamental frequency. So here it is told that root over T by rho into A is pi R square, that is equal to 600. This is given. So therefore we can say that it's 1 by 2 root rho pi into root over, and one L is also there, to T by R square, that is equal to 600. So now therefore we have to find nu naught dash, that is equal to 1 by 2 root rho pi into L dash into root over T dash by R dash square. So that will be equal to 1 by 2 rho pi, L dash is 2L, to this is T by 9 divided by R by 2 whole square. So that will be given as T by 9, that is 1 by 3 will come outside, and this is R by 4. So this will be 1 by 2 into root over 4 by 9 T by R square into 1 by 2 root rho pi L. So this will be 2 by 3. So this will be 1 by 3 into nu naught. So this is 1 by, since why here we see that nu naught dash, that is coming 1 by 2 into this, I can do 2 by 3 into this is 1 by 2 root rho pi L into root over T by R square. So this part is same as nu naught. This is nu naught. The previous frequency. So that is 2 and 2 will cancel. So that is 1 by 3 into nu naught. So it is 1 by 3 into 600. So that is 200 Hertz. So option A is the correct answer. Then it is told in question number 23, which of the following is incorrect? Which of the following is incorrect? If the wave is longitudinal, it must be a mechanical wave. If the wave is mechanical, it may or may not be a transverse wave. Um, Mechanical waves cannot propagate in vacuum. Then diffraction helps us to distinguish between sound wave and light wave. Yeah, so diffraction, so diffraction is a phenomenon which can be shown by all kinds of waves, but if we have a transverse wave such as light wave is a transverse wave, so it will show the effect of polarization. It will show the effect of polarization since it is a transverse wave. But since sound wave is a longitudinal wave, so it will not show polarization. So by using polarization, we can distinguish in between sound wave and light wave. So option D is incorrect. The statement given in option D is incorrect. So option D is the correct answer. And in the question number 24, it is told intensity level of sound whose intensity is 10 power minus 8 watt per meter square in decibel. So we know that the loudness of a sound that is given as 10 log I by I naught, and the base is 10 log base 10 I by I naught in decibels, where I naught is given as 10 power minus 12 watt per meter square. Okay, so I naught is 10 power minus 12 watt per meter square, and then I, so here I is given as 10 power minus 8 watt per meter square. So we have to find the loudness in decibels. Therefore the loudness will be given as 10 into 10 into log 10 power minus 8 by 10 power minus 12 in decibels. So this will be 10 into log of 10 power 12 minus 8 decibels. So this will be 10 power 4, so it will be 4, so that is 40 decibels. So option C is the correct answer. Then in question number 25, it is told the equation of a transverse wave that is given as 0.05 sine pi into 2t minus 0.02x, where x and y are in meter and t is in second. Then the minimum distance of separation between two uh, particles which are in phase. Okay, the equation of transverse wave is given by this, and t is in second. Then the minimum distance of separation between two particles which are in phase, and the wave velocity. Okay, so the wave velocity that is given as omega by k, if the equation of the transverse wave is given as y equal to a sine omega t minus kx. So therefore here omega is given as 2 pi and k is given as pi into 0.02. So k is in meter inverse and omega is in per second. Therefore the speed is given as 2 pi by pi into 0.02. So pi will cancel, so this is 2 by 100, so this will be 100 meter per second, and we have to find the minimum distance of separation between two particles which are in phase. So we know that sine 2 pi plus theta, that is equal to sine theta. So their phase difference should be 2 pi, phase difference. So therefore k delta x, which is, so their path difference, their minimum distance of separation, so k delta x, that should be equal to 2 pi. Then we can say that this delta x will be the corresponding value of the minimum distance of separation of the two particles which are in phase, the two particles which are in phase. So k is here 0.02 into pi into delta x, that is equal to 2 pi. So pi and pi will cancel out, so delta x will be equal to 2 by 0.02. This will be again 2 by 100, so this will be again 100 meter. So option B is the correct answer. So the minimum distance of separation should be 100 meter and the wave velocity is 100 meter per second. So both are 100. So option B is the correct answer. And then here it is told the frequency of the second overtone of the open pipe is equal to the frequency of the first overtone of the closed pipe. Frequency of the second overtone of the open pipe. Frequency of the second overtone. So for the open pipe, second overtone means it is the second harmonic. Sorry, first overtone is the second harmonic, and third harmonic is the second overtone. Third harmonic is second overtone. So here we know that when we have open end organ pipe, we have nu 1 that is equal to V by 2L. So nu 3, the third harmonic, that is the second overtone, that is equal to 3V by 2L. So that is 3 into nu 1. And that is equal to frequency of the second overtone, that is equal to the frequency of the first overtone in the closed pipe. So in the closed pipe, we have only odd harmonics. So here nu 1 that is given as V by 4L, since here lambda by 4 that is equal to L. So nu 1 is 4 by V by 4L, and then the first overtone means we have the third harmonic. So here we have the 3 lambda by 4 that is equal to L. So nu 3 that is equal to third harmonic is 3V by 4L. So that is 3 nu 1. The ratio of the lengths of the open pipe and the closed pipe, that is how much. So here suppose the length of the open pipe, so therefore it is told nu 3 that is equal to the third harmonic. So second overtone in open end organ pipe is same as the third harmonic in the open end organ pipe. Third harmonic in open organ pipe, that is equal to the third harmonic in closed organ pipe. Since why third harmonic in closed organ pipe is same as the first overtone in the closed end organ pipe. So therefore nu 3 that is 3V by 3v by 2l1, that is equal to 3v by 4l2. So we have to find the ratio. So suppose the length of the open end organ pipe is L1 and length of the closed end organ pipe is L2. So therefore we have to find L1 by L2. So here 3 and 3 will cancel out, 2 and 4, 2 to the 4. V and V also will cancel out. So here we get 1 by L1, that is equal to 1 by 2L2. So therefore L1 by L2, that is L1 by L2, that is equal to 2 by 1. That is 2 is to 1. Ratio is 2 is to 1. So option A is the correct answer here. Then is told in question number 27, a person with vibrating tuning fork of frequency 338 Hz. A person with vibrating tuning fork of frequency, that is 338 Hz, is moving towards a vertical wall. So the man is having a tuning fork. So he is moving towards a vertical wall. Sound. So his speed is 2 meters per second. And he is moving towards the vertical wall. Velocity of sound in air u, that is 340 meter per second. The number of beats heard by that person per second is. So the apparent frequency that is heard by that person, that is u plus v by u minus v into actual frequency. So therefore the beats frequency, the number of beats, that is equal to given as apparent frequency minus the original frequency. So that will be equal to u plus v by u minus v into nu minus nu. So nu, if I take as common, then this will be u plus v by u minus v minus 1. So that will be equal to nu into, this will be u plus v minus u plus v divided by u minus v. So u and u will cancel. So this is 2v by u minus v into nu. So therefore the beats will be 2 into v is 2 by u is 340 minus 2 into the frequency, actual frequency is 338. So 338 will cancel, that is 4 beats per second. So option B is the correct answer. Then it is told that a metallic wire of 1 meter length, there is a metallic wire is there. Metallic wire is there. It has a mass of 10 into 10 power minus 3 kg, and it is having a length of 1 meter length. Then if a tension of 100 Newton is applied to the wire, tension of 100 Newton is applied to the wire, then the speed of the transverse wave is. Metallic wire of 1 meter length has a mass of this. The tension is this applied to the wire, then the speed of the transverse wave is. Okay, tension is applied to the wire. Okay, then speed of the transverse wave, that will be given as root over t by mu. T by mu, where so it is t by mass per unit length, t by m by l. Okay. So the speed of the transverse wave, that will be given as t, tension is 100 Newton and mass is 10 power minus 2 divided by the length, that is 1 meter. So this will be root over 10 square by 10 power minus 2, that is 10 root over 10 power 4, that is equal to 10 square. So it is 100 meter per second. So option B is the correct answer. Then in question number 29, it is told that a train is approaching towards a platform. A train is approaching towards a platform. There is a platform A train is approaching towards a platform. Here we have a platform. Train is approaching with a speed of v, that is 10 meter per second, while blowing a whistle. The whistle is blown with a frequency nu, that is equal to 340 hertz. What is the frequency of the whistle heard by a stationary observer on the platform? What is the frequency of the whistle heard by a stationary observer on the platform? And given speed of sound u, that is given as 340 meter per second. So by using the rule of Doppler effect, you know that the apparent frequency, that is given as u plus minus v naught by u plus minus vs into nu actual. So where u is the speed of sound and v naught is the speed of the observer and vs is the speed of the source. So here the observer is at rest, so v naught is 0 here, and vs speed of the source, that is 10 meter per second. Now since the source is moving towards the observer, so the frequency should increase. So therefore the apparent frequency that will be equal to u by u minus vs into actual frequency, into the actual frequency. So that will be equal to u is 340 divided by, this is 340 minus vs, that is equal to 10 into the actual frequency, that is equal to 340 hertz. So this will be equal to 340 divided by 330 into 340. So this will be equal to, so this will be 34 by 33 . That is 1 plus 1 by 33 into 340. So this will be approximately, this is 340 plus 340 by 33, which is approximately 10. So which is approximately 350 hertz. So option D is the correct answer. Then in question number 30, it is told a pipe of 30 centimeter long and open at both the ends produces harmonics. So it means that we have an open end organ pipe which is open at both ends and it is having 30 centimeter length. It produces harmonic. Which harmonic mode of the pipe resonates at 1.1 kilohertz source? So it means we have, and given speed of sound v, that is given as 330 meter per second. So we have to find which harmonic resonates with this frequency. Let it be the nth harmonic. So nth harmonic is 1100 hertz. So that n we have to find which harmonic is that. So here we know that the first harmonic, which is the fundamental harmonic or the fundamental frequency, which is the first harmonic frequency, that is given as v by lambda. So here the first harmonic, the oscillation will be, the vibration mode would be like this. So here lambda by 2 equal to L, so lambda equal to 2L, so this will be v by 2L, and so nu n will be equal to, so here we have the nth harmonic. So here we have, here we will have actually, for second harmonic we have like this. So this will be, for second harmonic we have like this, lambda by 2 plus lambda by 2, that is lambda, so 2 lambda by 2. So here we'll have n, for nth harmonic we will have n lambda by 2 equal to L, so lambda will be equal to 2L by n. So this will be V by lambda, which is N V by 2L. So now, therefore, we have to find first which is N into nu 1, N times the first harmonic frequency. So it means N, the nth harmonic frequency is equal to N times the first harmonic frequency. Now the first harmonic frequency you have to find, V by 2L, that will be equal to 330 by 2L, 2 into 3. So 30 centimeter means it is 0.3 meters. So 2 into 0.3. So this will be 330 by 2 into this will be 3 by 10. So that 10 will go up. So 310 will be 1100 divided by 2 hertz. Now therefore nu n is 1100 hertz. That is equal to n times nu 1. So that is equal to n times 1100 by 2 hertz. So it means that these two will cancel. So n by 2, that is equal to 1. So n is equal to 2. So it is the second harmonic. So it will, so the second harmonic mode of vibration in the pipe will resonate with the 1.1 kilohertz source. So it means option C is the correct answer. Then it is told that a stretched string is vibrating in the second overtone. A stretched string is vibrating in the second overtone means it is like this. Sorry, second overtone. First overtone is this. So this is the first overtone, and the fundamental frequency is this, obviously. And the second overtone would be like this. Second overtone. This is the second overtone. So it means that 3 lambda by 2, that is equal to L here. So lambda will be equal to 2L by 3. And so the frequency, so here we will have the vibrating second overtone, then the number of nodes and antinodes between the ends of the string are. So in the second overtone we have 3 nodes and we have 3 antinodes. Here we have 3 antinodes. So in between the ends of the string, so in between the ends, so we should exclude the ends. So we have 3 overtones, so we have 3 antinodes and 2 nodes. So here we have, so nodes means, so 1 2 3 4, so we have 4 nodes and 3 antinodes. 31. So option C is the correct answer, since we have 4 nodes and 3 antinodes here. Then in question number 32 it is told, when two tuning forks A and B are sounded together 4 beats per second are heard, the frequency of the fork B is 384 hertz, and their beat frequency means nu mod of nu A minus nu B, that is equal to 4 beats per second. Now when one of the prongs of the fork A is filed and sounded with B, the beat frequency increases, then the frequency of the fork A is. Now when, so we know that when one of the prongs is filed, then the frequency will increase. One of the prongs of the tuning fork, is filed, then the frequency increases. Frequency of the tuning fork increases. The frequency of the fork A is how much? Then frequency of the fork A is how much? That we have to find. So and it is told when one of the prongs A is filed and sounded with beat, the beat frequency increases. So it means that So it means that therefore new A should be obviously more than new B. Since why? When new A increases, then new A minus new B also increases. So therefore new A minus new B, that is equal to 4. So new A will be equal to new B plus 4, that is equal to 384 plus 4 is equal to 388 Hertz. So option A is the correct answer. So if you are unable to understand any of the steps of the solution or any other doubts you are having, please write us in the comment section. Uh, Question number 33, it is told a source of sound. There is a source of sound which is moving with a velocity of 50 meter per second towards a stationary observer. There is a source of sound which is moving with a velocity of 50 meter per second towards a stationary observer. So a stationary observer, it is at rest. The observer measures the frequency of sound. The frequency sound, suppose the actual frequency is nu, and the apparent frequency of the sound which is measured by the observer, nu one, that is 500 Hz. The apparent frequency of sound as heard by the observer, then what is the apparent frequency of sound as heard by the observer when source is moving away from him with the same speed? So when source is moving away from the same speed v. Speed of sound at room temperature is 350 meter per second. So speed of sound u, that is given as 350 meter per second. So according to the Doppler effect, by the rule of Doppler effect in the sound waves, we have that the apparent frequency is given as u plus minus v naught by u plus minus vs into actual frequency, new actual, where u is the speed of sound and v naught is the speed of the observer and ps is the speed of the source. So here the observer is at rest, so v naught equal to 0, and when source is moving towards the observer, so therefore source is moving towards the observer, so apparent frequency should be greater than the actual frequency when source is moving towards observer. Source is moving towards the observer. So therefore the apparent frequency, that will be equal to u by u minus vs, where vs is given as v, the source speed of the source is v. So this will be u by u minus v into nu. Suppose the actual frequency is nu naught, so into nu naught. So that is given as 500 Hz, and then we have to find the apparent frequency nu 2. So nu 1, that is u by u minus v into nu naught is equal to 500, and when source is moving away from the observer, source is moving away from the observer, then the frequency will decrease. So then we have the apparent frequency will be less than the actual frequency. So therefore we can say that the apparent frequency that will be given as u by u plus v into nu naught when the source is moving away from the observer with the same speed. So then that value we have to find actually, which is equal to nu 2 actually, which is equal to nu 2, that we have to find. Therefore now nu 1, that will be equal to that is equal to u by u minus v. So u is 350. So 350 by 350 minus v. Now the v is given as 50. So this will be 50. 350 minus 50 into nu naught, that is equal to 500. That is nu 1. So from here we can find nu naught. 350 by 300 into nu naught, that is equal to 500. So therefore nu naught will be equal to the actual frequency, which is 500 into 300 divided by 350. So 0 will cancel. 5 sevens are 35. So this is 3000 divided by 7 hertz. Now therefore we have to find nu 2, that is equal to u by u plus v into nu naught. So u is 350 by 350 plus 50 into nu naught, which is 3000 by 7. This will be 350 into 3000 divided by 400 into 7 hertz. This will be 7 5s are 35, then 5 8s are 40, so 3000 divided by 8. So this will be equal to 3 into 1000 by 8. So this will be 4 2s are 8, 4 25s are 100, 250, so this is 125. 3 into 125 means this is 75, 375 hertz. So here option C is the correct answer. Excuse me. So here we shall end the first part of this waves, and in the second part of this video we shall solve the remaining 4 to 5 questions, and we shall start the next chapter also, which is the electric field. So hope you have understood the solutions. If you have any other questions or any other doubts, if you have, please write us in the comments section, and please install our Sapience education application, whose link has been provided. So here we shall end the class. Thank you.